Researchers concluded that the ray's negative particles...
Silver-plated jewelry.
Yeah.
Gold-plated jewelry?
Sure.
6.
Now, do you understand that they are taking basically metals in solution, running electricity through it, and then making metal onto the other metal, silver-plated, gold-plated? The next thing they did, they decided to make silver in the amount of 108 grams. So they ran electricity through the silver solution until they got 108 grams. Jacob. So once they got 108 grams, they got the electric bill from the company. The electric bill is the Faraday constant. That's the amount of energy it took to make 108 grams. Here, why are some magnets stronger than others? Now, we didn't necessarily talk about this yesterday. I'm making a bell work just because I want to know if you've ever heard of it before. You might have talked about magnets in middle school. It's a fairly common topic there. So anybody know why some magnets are stronger than others? Jimmy?
Electrons are greater than protons.
Used to suspend the electron in the experiment. Raise your hand. Zane?
Charge?
No. What did he coat the electrons with? What? Raise your hand. Raise your hand, Lou. Oil, yes. Oil is what he's using there to suspend that electron, because it's not going to do it on its own, right? It's going to have something to help suspend it. So oil is what was magnets stronger than others. There are 4 or 5 reasons for this, namely size. Write this down. These would be notes. Why are some magnets stronger than others? So we have size would be number 1. You can have a very large iron magnet, steel magnet, and it's going to be stronger than a neodymium magnet. The bigger the magnet is, the stronger it will be. Atomic number is equal to the number of protons and electrons. So in a neodymium magnet, you have neodymium, iron, and boron. And you can see that they have atoms in that magnet with different numbers of electrons. So they're going to be trading at different rates. Brendan, you might want to write this down. That would be a note. We just discussed that magnets are found in all electronic devices, and they're associated with data storage. Metal by running electricity through it.
Yeah.
Give me an example.
Gold-plated jewelry.
You ever heard of gold-plated jewelry?
Yeah.
Or silver-plated jewelry? That's basically what they're doing. White TV or color TV? Black and white. So if you look at the cathode ray in this picture right here on page 108, when the line strikes and produces a little dot of color, do you think that's going to be the white on the TV or the black? That's going to be the white. If you go back and you purchase the original black and white TV, they were not 1080. They were very fuzzy. So the white that you were seeing was actually, it wasn't this color, but it was a similar screen. That when you struck it, it was producing the light. And then when they made improvements, and the black and white was replaced with color. However, it was not 1080. It was probably like, at best, 300. 1080 is very good today. This is 1080 up here. Of a single electron important. If you know the charge of a single electron, let's say you have 1,000,000 electrons. You can add that together and you'll know the charge of that group of electrons. You'll know the voltage associated with that group. So you can better charge people, like if you have an electric bill, you can say, this is how I know what you've used, if you know what a single is. Is that clear?
At the start of the experiment, atomizer sprays a fine mist of oil droplets out of hydrogen atoms, the lightest known atom. The conclusion was shocking because it meant there were no particles smaller than the atom. In other words, Stalin had been incorrect. Atoms were invisible into smaller subatomic particles. Because Dalton's atomic theory had become so widely accepted, and Thomas's conclusion was so revolutionary, many other scientists found it hard to accept his theory. Thomson was correct. He had identified that the first subatomic particles.
Homework on the gold foil experiment.
Cut.
Go.
In this ferrous oil is sprayed into the chamber above. The two ferrous large plates top plate have a small hole through which the oil.
All important.
Because it's the most important number.
If I'm selling eggs, right, and I don't know how many are in the carton, and one day I give you 10, and the next day I give you 12, are you going to come back to me and say there's a problem here?
No.
Well, you're missing your 2 eggs the next day, right? Now you're paying for 12 and you only got 10?
Yeah.
If you don't know what you're selling, you can start to take advantage of people. That's why the mole is so important. It tells us exactly, not exactly, but it tells us approximately what we're selling.
It will measure both the amount of electric force and the magnitude of electric field on the tiny charge.
You used the X-ray to get the charge on the oil droplet, Michaela. I'm impressed. You were paying attention. Very good. Excellent. You've never heard of silver-plated jewelry.
Yeah.
The oil drop experiment would not work well without the atomizer. So help us understand where we might find a current-day atomizer. Heather? Where would we find a current-day atomizer? Claire? Sophia? Now on this sheet, at the bottom of this sheet, it says how the atomizer works. And in this definition here, it provides you an example of where you would find one. So raise your hand if you know the answer.
I said no,
Why?
because magnets are mixtures of different metals.
Very good. Magnets are mixtures of different metals. Are metals on the periodic table magnetic? So their magnets are mixtures. So what about elements in the periodic table, Eliza? What do? Well, they form bonds. Remember the name of the bond? Starts with an M. Metallic. Who said that? Heather. Yes. Yes, the metallic bond, like Metallica. So it's a metallic bond in the sense that electrons are being traded, and if you have 2 identical twins, right, they tend to want to trade at the same rate. That's kind of what's going on. Like we cloned you, cloning would probably be better. We cloned everybody, it would be bad. We'd kill each other faster. Because it would be hard to distinguish between people. You know, if you did something wrong, what does it look like? It looks like you, right? So fighting usually results from things happening bad, and that's why there would be a problem. But the point is that metals that are elements, they trade at the same rates, right? They trade at the same rates because of their family, the group that they're in. Basically, their valence electrons define their behavior, and if they have a certain number of electrons out there, it's not going to change because that defines you. The element, protons and electrons define the element. So if you have a certain number of electrons, you're going to trade those electrons. Make sense? And if you're trading the same thing, you can't have an area of loss and area of gain. That would be a magnet.
This charge was later equal to a single unit of negative charge with one negative. In other words, a single electron carrying charge. Some good was Millikan's experimental setup until he pulled a charge he measured almost 100 degrees below the amorphous without it.
Okay, so why is the Millikan oil drop experiment important? Anybody know? Without the Millikan oil drop experiment, we would not have the mole, which is the most important number in chemistry.
The space between the metals closes ionized by radiation. Electrons from the air attach themselves
To put in simply, the atomizer, whether the atomizer, are the same along the line, using a heating element to vaporize the heat.
Yeah, vape, e-cigarette. An e-cigarette, that is basically an atomizer. So let's read where the description of the atomizer and how it works. Okay, one of the dangers with atomizers would be the nicotine. So you go buy the nicotine because people don't want to smoke, right? The problem is nicotine is in a bottle and it's concentrated. If you spill it on your skin, guess what? Right, very good, Cody. The nicotine will go into your bloodstream. It can be absorbed through the skin. Now, yesterday we had a department meeting, right? And the department chair, she said, we can no longer have iodine in the lab. And a lot of the, one of our colleagues, they're not happy about that. They're like, iodine, what are you talking about? They rub iodine on you when you go into surgery. Well, the problem is when we order it from a chemical supply company, it comes in concentrated form. And in concentrated form, it's different from when you're going to get treated like at the hospital. They dilute it a lot. So taking it from concentrated into the concentration you want is where the danger lies. So if you get it on your skin, it can be very, toxic to you. That's the issue. And if you let kids handle it at different levels of toxicity, somebody has gotten hurt. So the only reason why they would say we can't use it anymore is somebody got like high iodine exposure.
Sprayed into the upper chamber with an atomizer. Some of the tiny oil droplets fell through the hole in the upper floor, and Millikan was able to determine the mass of an oil drop from its terminal velocity. Next, Millikan used an X-ray source to ionize gas molecules in the chamber. Electrons from this ionization process adhered to the oil droplets. The oil droplets now carry a negative charge. The negatively charged oil droplets can be halted by adjusting the voltage across the two plates. As the voltage across the plates is increased, the velocity of the oil drops slows. As the voltage is increased further, some drops will begin to move upward toward the positive plate. If the voltage is set just right, an oil drop can be suspended. When an oil drop is suspended, its weight, mass times acceleration due to gravity, is exactly counterbalanced by the electric force applied. The electric force applied equals the applied electric field, E, times the charge on the drop, Q. Since the mass of the oil drop, the acceleration due to gravity, and the applied electric field are known, Millikan could solve for Q, which is the charge on the drop. Millikan found that droplets had different charges, but each was a whole number multiple of a smaller charge, equal to negative 1.60 times 10 to the negative 19th coulombs. Millikan...
You have an audio which is connected to a circuit board as well as a power supply. The circuit board, when active,